Welcome back to another explainer. Okay, let's dive into this. Today, we're tackling a major plumbing upgrade that, well, so many of you are curious about right now. Tankless water heaters. Specifically, we're going to figure out exactly how to calculate the perfect size unit for your specific home. No more guessing.
I mean, picture this. You're enjoying a nice, hot, relaxing shower, right? And then someone else in the house turns on the kitchen sink or starts a load of laundry, and bam! You are hit with a freezing cold blast of water. Yeah, it's literally the worst. Today, we're looking at exactly why that happens, and more importantly, how to prevent it. You see, unlike your traditional tanks that just sit there holding a giant reservoir of hot water, tankless heaters don't store anything. They're incredibly efficient because they heat the water completely on demand as it flows through the unit. But because of that on-demand magic, sizing them correctly is absolutely critical.
And that brings us to the most important acronym you need to know today, GPM, which stands for gallons per minute. This is the absolute key sizing metric for tankless systems. It literally measures exactly how much hot water a unit can physically deliver right when you ask for it. If you go and pick a unit with too small of a GPM rating, well, you don't just run out of hot water eventually, you instantly notice a drop in pressure, reduced flow, or just plain lukewarm water the second somebody else turns a tap on.
So, to prevent that sudden blast of cold water, we've got your tankless sizing blueprint right here. We'll start with the magic metric, GPM. Then, step 1, temperature rise. Step 2, peak demand. After that, matching demand to capacity. And we'll wrap up with some hidden performance factors you definitely need to know.
All right, starting off with the magic metric, GPM, the true foundation of tankless sizing.
Moving on to step 1, let's talk about temperature rise and the actual physics of heating water. So what is temperature rise? It's basically just the mathematical difference between your incoming cold water supply and your desired hot outlet temperature. Now for most homes, your finish line is about 120 degrees Fahrenheit. That's the highly recommended sweet spot for showers and running the dishwasher, mostly to prevent any risk of scalding. But to figure out your temperature rise, we really have to figure out where your starting line is.
Now, what's really interesting about this slide is how much your local geography and climate completely dictate your heater's workload. Think about it. If you live somewhere with freezing winter, supply water, let's say it's 55 degrees coming into your house, your heater has to pull off a massive 65-degree temperature rise just to hit that 120-degree target. But in a milder climate, where the incoming water might be a comfortable 70 degrees, well, the heater only needs a 50-degree rise. It's the exact same finish line at the tap, sure, but that winter scenario forces the exact same piece of equipment to work significantly harder.
And because of that physical reality, a heater's real-world GPM can drop drastically when the required temperature rise is higher. You absolutely always have to check a unit's rated conditions before you buy it. You see, a manufacturer might advertise this amazing GPM flow rating in massive print on the box, but those numbers are directly tied to very specific inlet and outlet temperatures tested in a lab. If your groundwater is colder than their lab, your actual flow rate is going to be lower than what's printed on the box. It's just a fact.
Okay, step 2, peak demand. It is time to audit your household fixtures.
This is where we put on our detective hats. Take a quick look at this menu of common rough benchmarks. A standard shower pulls about 1.5 to 2.5 GPM, though if you've got a modern low-flow shower head, that drops down to roughly 1.0 to 1.5. A kitchen faucet, usually around 1.0 to 2.2 GPM. A dishwasher ranges from 1.5 up to 3.0 GPM during its active fill cycles, and laundry is commonly sitting around 1.0 to 2.0 GPM per machine. To size your system properly, you literally just go down this list and add up the GPMs for anything that might realistically run at the exact same time in your house.
So the crucial point is identifying what we call the critical moment. You aren't sizing your heater for a random, quiet Tuesday afternoon when nobody is home, right? You're sizing for absolute peak demand. We're talking about that hectic morning routine. Maybe one shower is running while someone else is in the kitchen making breakfast and running the faucet, or maybe you have two people taking showers in totally separate bathrooms at the exact same time. Your tankless sizing has to match your household's likely peak demand during those specific, high-stress, critical moments.
Which brings us to matching demand to capacity. Basically, doing the math.
All right, once you've summed up your expected simultaneous flow, you compare it to the unit's rated GPM specifically at your temperature rise. Let's look at this in practice with some typical household scenarios. Say your critical moment is just a single shower plus a kitchen faucet that gets used occasionally. You're going to need roughly 2.0 to 3.0 GPM of combined capacity. If your household demands 2 simultaneous showers, boom, you're jumping up to 3.0 to 5.0 GPM. And if you have a full simultaneous demand, like 2 showers plus a dishwasher all running at once, you should definitely expect much higher GPM requirements. And remember, if you absolutely love those luxury, high-flow shower heads, or if you have very cold inlet water in the winter, that is going to push you aggressively toward the higher end of these ranges.
Now, here's a pro tip. No matter what your final calculation says, always, and I mean always, add a safety margin to your peak demand. Real-world household usage can be super unpredictable. Guests visit for the holidays, daily routines suddenly change, teenagers start taking notoriously long showers. You get the idea. Undersizing a tankless heater is incredibly frustrating because it shows up immediately as reduced flow or worse, water that never quite reaches your target temperature. So do yourself a favor and give yourself a buffer.
And finally, let's look at some hidden performance factors, the real-world variables.
So let's step away from the perfect paper math for a second because real-world variables can really cause a system to struggle if we aren't careful. We already talked about how cold inlet water increases the temperature rise, which cuts down your max flow, but you also need to think about your energy source. Gas and electric models actually have completely different capacity limits based on your home's available power or gas supply lines. Then there are flow restrictions. If your home has really long, winding pipe runs or just generally low water pressure from the city, that is going to reduce the actual hot water performance at the fixture itself. Oh, and lastly, your temperature set points. If you decide to crank the target temperature on the unit way above 120 degrees because you want it boiling hot, you instantly lower the available GPM that unit can push out.
So, what happens if your home's critical moment requires just a massive amount of hot water that one single unit can't handle? Well, if you have high simultaneous demand, really complex plumbing needs, or heavy usage, you should seriously consider multiple tankless units zoned by bathrooms or even by floors. A professional load calculation might just reveal that a single unit is always going to struggle in your specific home. In that case, going with multiple zoned units is an incredibly smart upgrade that practically guarantees flawless performance everywhere in the house.
Which brings us to a final, slightly provocative thought to leave you with today. Ask yourself, does your home's critical morning routine require a professional load calculation or maybe even multiple zoned units? I highly recommend taking the blueprint we've gone over in this explainer today. Audit your daily fixtures and map out your household's exact GPM needs. It's truly the absolute best way to ensure you have strong, piping hot water exactly when it matters most without ever getting hit with that sudden blast of cold water again. Thanks so much for joining me, and hey, happy calculating!